Okay, I just wanted to put together a few problems for you guys to look at for review. This is in addition to the review assignment that you have, so it's not like a totally exhaustive list, but hopefully it'll help you to think about some things. Um, First off, just a reminder of how to find the trig functions given one of the trig functions. We've got secant is equal to 5 over 2. Now remember, secant is the inverse function of not the inverse function, the reciprocal function of cosine. So if secant is 5 over 2, then that means that our hypotenuse is going to be 5 and our adjacent side is going to be 2. But it also tells us that sine is negative. So think about secant is positive both in the first quadrant and in the fourth quadrant. But for sine to be negative, it's going to have to be in the fourth quadrant. So, because this is positive, like if we call this y, then this is the negative of that. So, in order for sine to be negative, that's going to have to be negative. All right, so to find the y value, we're just going to use our Pythagorean relationship. 2 squared plus y squared is equal to 5 squared. So that's 4 plus y squared equals 25. And we get y squared equals 21, so y is the square root of 21. And so this is going to be negative root 21, and that's our actual theta, the one in the fourth quadrant. Okay, so to get all the other trig functions, secant is 5 halves, cosine is just its reciprocal, so that's easy enough. That's going to be 2 over 5. Sine is going to be the opposite over the hypotenuse, so negative 21 over 5, and then its reciprocal cosecant would be the reciprocal of that. We got to rationalize though to get negative 5 root 21 over 21. Okay, so that just leaves tangent. Tangent we know is opposite over adjacent, so that gives us negative 21 root 21 over 2. And then its reciprocal function cotangent would be negative 2 over root 21, but we rationalize to get negative 2 root 21 over 21. Okay, remember one of our easiest little methods in verifying our trig identities and simplifying our trig identities is just to change our expression to terms of cosine and sine only. So here we've got cosine times tangent times cosecant, and we can just write this as cosine theta. Tangent we rewrite as sine over cosine, and then cosecant is the same as 1 over sine since it's the reciprocal of sine. It might help if I change my cosine to cosine over 1. But then we can just see our cosines are going to cancel out and our sines are going to cancel out. And it simplifies very nicely to 1. If we're asked to simplify an expression like this one, 1 plus 1 over tan squared x, we just have to keep in mind our reciprocal identities. Since 1 over tangent is the same as cotangent, 1 over tangent squared would be cotangent squared. And 1 plus cotangent squared, hopefully you recognize that as being one of our Pythagorean identities. So 1 plus cotangent squared gives us cosecant squared. And remember, the only way you can really get used to using these is just to think about them or use, practice working with our trig identities. A quick refresher on that, if I've got x squared plus y squared equals r squared, in this particular case, if we divide each of the terms by y squared, which, dividing both sides of the expression by the same thing doesn't change anything. But x squared over y squared, we know, is equal to cotangent. And then y squared over y squared is 1. And then r squared over y squared, we know that y over r is sine. So r over y would be cosecant, and r squared over y squared is cosecant squared. So we can think about those identities and just kind of recall them without having to memorize them. On this problem, we're asked to simplify the expression 1 over 1 plus sine x minus 1 over 1 minus sine x. And what we want to do is first find a common denominator. They're both prime, but if we multiply 1 plus sine x times 1 minus sine x, we get a difference of two squares, 1 minus sine squared x when we multiply them together to get our common denominator. So I'm just going to write each of these with our new denominator. Okay, since we had to multiply 1 plus sine x times 1 minus sine x to get the new denominator, we multiply 1 times 1 minus sine x. And the same thing here, since we multiplied 1 minus sine x times 1 plus sine x, we've got to multiply the numerator times 1 plus sine x as well. And so that gives 1 minus sine x minus 1 plus sine x over 1 minus sine squared x. And we got 1 minus 1 cancels. Minus sine x minus sine x. That's going to be minus 2 sine x in the numerator. And then 1 minus sine squared x in the denominator. Alright, so minus 2 sine x, I'm going to leave that for now. But the denominator, remember, I'm going to go up here for a second. Our denominator, if we think of cosine squared, our Pythagorean identity that we've looked at a whole lot, cosine squared plus sine squared equals 1. 1 minus sine squared gives us cosine squared. And so we've got it kind of simplified, but we could actually write it without a fraction, and recognize that if we have minus 2 sine x and then cosine squared, write that as cosine x cosine x. I think the homework problem I got this from was a multiple choice problem where you had to choose which one it was related to. And although there's not a unique answer, if you're given a choice, so you can see that sine x over cosine x simplifies to tangent, and then 1 over cosine x is secant. So the actual choice was negative 2 times secant x, and then sine x over cosine x is tan x. So this is the, I guess, answer that the multiple choice answer that they were looking for. But again, it's not, there's no one correct answer. A lot of times you're just looking for the expression that is equal to the one that you have. So, these two are equal. It could have been this, but in the particular problem that I grabbed it from, they were looking for this one, and that was the only choice that worked. To simplify cosine of x minus pi over 2, we are going to use the property cosine of a minus b, just one of our sum and difference formulas, is equal to cosine a cosine b plus sine a sine b. So cosine of x minus pi over 2 we can write as cosine x cosine of pi over 2 plus sine x sine of pi over 2. And pi over 2, we know this is this point up here on the unit circle. So that's our x value is 0 and our y value is 1. We know that our cosine is the x value, so this is going to be cosine of x times 0 plus sine of x times sine of pi over 2, which is 1 because it's equal on the unit circle to the y value. So we get sine of x. Okay, on this one we want to use sum or difference formulas to find the exact value. So there's really no trick to thinking about pi over 12 in terms of two other values, but you just kind of have to practice at it. And what I'm going to do is pi over 12, think about this is equal to 1/12 pi, and know that we have values. It's going to turn out to be 1/12 is equal to 1/3 minus 1/4. Okay, because if we think of our angles being denominations of 3 and 4, like 1/3 minus 1/4, this is 4/12 minus 3/12. And again, you just kind of have to practice coming up with those calculations, I guess. But you'll see enough of them, you start to think of the denominator 12. Okay, well, I know what pi over 3 is, and I know what pi over 4 is. So I can do 2 pi over 3, I can do 3 pi over 4. So just think of your common radian measures, and it will help you to get that. But anyway, pi over 12 can be written as pi over 3, which is 1/3 pi, minus pi over 4, or 1/4 pi. So pi over 3 minus pi over 4 is how we're going to do this. And so sine of pi over 3 minus pi over 4, that's going to be a difference formula. And the difference formula for sine would be sine of pi over 3 times cosine of pi over 4 minus cosine of pi over 3 times sine of pi over 4. And so we just have to think about also now our angles for pi over 3 sitting on the unit circle. Pi over 3 has 1/2, and then square root of 3 over 2, and 1 for our angle measures. And then pi over 4 sitting on the unit circle, it's 45 degrees. We have square root of 2 over 2, square root of 2 over 2, and 1 for the sides of our triangle. Alright, so sine of pi over 3 would be square root of 3 over 2, and then cosine of pi over 4 is square root of 2 over 2, minus the cosine of pi over 3 is 1/2 times the sine of pi over 4, square root of 2 over 2. So we get the square root of 6 over 4 minus the square root of 2 over 4. Okay, here we just recognize that our sum formula for tangent is just tangent of A plus B is equal to tan A plus tan B divided by 1 minus the product of tan A and tan B. And so it's very obvious that we have the form presented, and so this would equal tangent of 84 plus 96, which is the tangent of 180 degrees, and that's very nicely one of our quadrantal angles. On the unit circle, think about the x value is going to be -1 and our y value is 0. Tangent is equal to tangent of theta in general is equal to y over x. So our tangent of 180 is equal to 0 over -1. So tangent is just equal to 0. By y equals cosine inverse of 0, what we're looking for is the value of theta whose cosine is equal to 0. And if we just think about our cosine 0, we remember our cosine is equal to the x value. So if we think on the unit circle, the x value is 0 here and here. So we would just say y could either equal pi over 2 or 3 pi over 2. Okay, we want to solve the equation 3 cotangent x plus 1 equals 4. So first thing we want to do is just isolate our cotangent x. We get 3 cotangent x equals 3, and cotangent x equals 1. Now remember, cotangent of x is equal to our x over y. So when we're saying that the cotangent is equal to 1, we're looking for the one place on the unit circle where the x and the y values are the same. And we know at this point that that corresponds to pi over 4, root 2 over 2 for x, and root 2 over 2 for y, because those are the ones that fall along that line, y equals x. Oh, excuse that there, but two places that occurs here on the unit circle, negative root 2 over 2, negative root 2 over 2. And so in the first quadrant, that corresponds to x equals pi over 4. And then the place in the third quadrant where the x and the y values are equal to each other is 5 pi over 4. For this particular problem, the best thing to do is recognize that we have an equation that is quadratic in form. So we have something squared as our first term, and then that same something, and then a constant term set equal to 0. So what we could do, you don't actually have to do the substitution. You might recognize that it is quadratic, and you're able to factor it just fine. But what you can do is say let u equal sine x, and if u is equal to sine x, then what we have here is 4u squared plus 8u plus 4 equals 0. And so we just recognize it to be a quadratic equation. And if we solve that, I'm going to first factor out a 4 because we can. So we've got 4 times u squared plus 2u plus 1 is equal to 0. And so we have u plus 1 quantity squared, or u plus 1 times u plus 1 equals 0. And if I am solving this using our zero factor property, then what we have is u plus 1 equals 0, or u equals -1 as our solution. But remember that u is equal to sine x, so this is actually sine x equals -1. And we know that sine on the unit circle is given by our y value, and so the place that the y value is equal to -1 is down here at 3 pi over 2. Okay, so a problem like this, We could just say tan squared x equals -2, and obviously there are no values that when we square it we get -2, so our answer is just going to be no solution.